Right. Welcome, guys, to our second presentation on the usage of STATA 19 to analyze the data which we are given, students' data and wage data, also the use of system automatic data and web use data. We are taught to analyze data using dataable summaries, box plots. Someone's mic, I think it's on. Can you please try muting? So, um, we had about 10 tasks. So here instead, we're just going to showcase whatever we have done, which most of the explanations will be done using the R Studio and collab, Google Collab. So be running our commands in this to file. So first of all, we're going to load data and encode data since our data is in strings, most of the variables. Now we don't need bytes to analyze data. Oh, let me see. Program star 19 using okay. I have this here as my log file. I changed it. So let's just remove this for the sake of the other analysis. Okay, from here. So let's run this code and check. Now, this is just giving us frequency, percentage, and cumulative, just showing gender distribution in our data. So we have about 46% of females and 53% of females. And as I have already said, we have encoded some data, which is here, the encoding of strings to numeric variables to help our data analysis to be run smoothly. Going to the going to our first task, which was to summarize the data using the table. Now, this is our command. This will only work if our data are in bytes and not in strings. So we have already done that. So this is our table analysis. Just in summary, showing us what's there in our data, as we have already been told that we had 159 students, which I'm representing their relevance reading. So let's go to another command or another execution from the do file. I hope the screens are visible. If not, that might be a network issue, but I hope they're visible. Our second task was to showcase the analysis or analyze using. All right, thank you, sir. Using a bar graph, we had to showcase gender distribution in the bar graph. So if we run our command there, we should expect graph somewhere here to pop up, which visually analyze our data. So let's just wait a second for the graph. Yeah, so this is our data using a bar graph presentation. So yes, much of the explanations, of course, will be done in our studio, but we can see in nuclear family where we have the most highest score of males, since here we have female here, male, and in child-headed family and step family, that's why I have lowest number of females, two, and in these two child-headed and step family, we have no any score of what? Of females. So moving on to the third task, which was to show the edges across programs using a heat map. All right, let me take this command and execute it and see the outcome. So should also just wait here for the heat map to pop up. Yeah, so this is the heat map. We have the legend there. So this color intensity represents mean student age in each word in each program. The darker shading, which looks bluish but dark, is showing us, or it's representing high average age, and where the light cells indicates at least composition in those programs. Thank you. Let's move on to another task. So these are the notes which are in the do file. I think it is included in the overlay presentation. I also had to run a kernel density plot showing the same male versus female ages. So let me also run this. I won't be running the other one. Let's wait for the kernel density graph to pop up, and most of the descriptions are in the overlay presentation. Oh,
Sir, sir,
is it?
sir,
Hello.
you are on the do file. We're not
I
seeing
I
the log
I
file with the results.
I, I can't hear you properly. Sorry, but we'll take the questions, or most of
Okay,
the questions will be asked in the Google Colab. So we ran a kernel density. So this is the graph where it's showing a list, uh, of- where it's showing a list. There are more females here, which we already saw. It was about, I think, 56%. So the overlapping is also showing us that in the overlapping is also showing that gender sometimes. Okay, let me start with the peak. At the peak, show the most ages in either for males or females. So we have the highest, which are the females, and the lowest are the males. All right, let's get to, I think, the last part. So these are the notes or the interpretations on the density graph. We also told task number 5 to at least have a box plot, a box graph, which let's just run the command and appreciate it. All right. So this is the box plotted, which at least is showing the distributions of males and females according to their gender. So as we can see, at least the males are at the highest level in this. Okay, let's go to another task, which we were given. wage data to analyze tenure, education. Thank you. So first of all, let us clear whatever data we had. We're going to describe the data and run the regression analysis, which wage is our dependent variable, which should be influenced by education, experience, and tenure. So let us appreciate this. So now this is our, first of all, we describe data and then we summarized the wage, education, experience, tenure. So it's showing us at least the minimum number of, like at wage, minimum salary, and maximum education attainment. So from year 0 to at least 18 years in schooling, and also experience of work, at least 1 year experience to up to 51 experience, retirement age somewhere there, and also tenure for how long, from 0 at least 44. So these are the standard deviations. And from this, uh, we have an F statistic, which is 0.00, showing us the model is significant, and also our R squared, which we explains these variations are at least explaining 30% of what of our wage, which is our dependent variable. So we can see education is indeed affecting wage positively. So all these up to tenure. So education affects wage that much highly, as we can see our T score and P score, and also a bit of experience affects tenure, but not significant, as it is greater than 0.05. So now this was our regression analysis, and let us also appreciate. So all these are the interpretations, and also we did some diagnostic checking where we found we had heteroscedasticity in our data, but we didn't find any multicollinearity in it. So we had a last part which we had to analyze marginal effects. Oh, since this is the web-use data, so let me just run all these statistics from, okay, task 8 up to 9. So it's a web-use data. We start from there. And also the other data, it was system data. So close file, no, not that part. Okay, let's start from there. Let's try running this. I don't know if I changed some data, but yeah, so oh, these are explanations. Uh, we started from task number 8, not 9. Okay, those were done. Now we describe the data. We had to tabulate our birth weight based on how we had to tabulate race and also smoking. Does it affect the birth weight based on age of mother, the race, and the smoking during pregnancy if the mother is pregnant? So we had to do that, and the interpretations are both in this do file and also, how many minutes? 20 minutes. And also in our overlay presentations. So in conclusion, this was our STATA analysis. Of course, we did probit model and the logit model, which are basically models dealing with probability, which you either choose. If it is a 0, you might take it. If it's a 1, you might leave it. So basically, all those presentations or interpretations are in our slides, PowerPoint. So reaching this far, thank you once again. I'm Yasin. More questions and interpretations will fall on Google Colab using the R Studio. Thank you. I hope you got it. And if anything, you can comment on.
All right. That was a very good presentation, and we understood most of the parts. I just wanted to. I hope you can hear me. Hello.
Yes, can hear you.
Yes, yes.
Yes, hello.
Uh, I just wanted to comment a bit on the Kenyan density plot. Hello.
Yes, hello. You audible?
Okay. So
Audible
I said
enough.
I just. All right. I said I just wanted to comment a bit on kernel density plot. So the kernel density plot also shows the concentration. The concentration. So how it works, the higher the curve, the more students fall in that age range. I don't know if it's possible if you can bring back the graph.
All right. Try looking for it. So I cannot density curve. Okay, it's loading.
All right.
All right, just a minute. Let me share the screen.
Right.
Okay.
Right.
I hope you can see my screen.
Not yet. I think on
Not
my
yet.
side
It's
maybe
still
a little
something.
bit of network. I don't know.
All right, I've shared it. I don't know, maybe let's just wait for the network.
Okay. For those who observed it properly, we had the female curve, which was presented by the red line, and the male curve, which was being presented by the blue line. That is. So, uh, simple interpretations of these. Okay, so the the female curve, which is which was being presented by the red lines, those ones, we are showing ages around 20 to 21 years, um, meaning most of the females were tightly clustered around those ages, and there was less variation. So the males who were being shown by the uh, blue lines were being presented mostly by 22 to 23 years. Um, a basic interpretation of this shows that the average, on average, most males are, are, are slightly older, and it's a more spread out age than the females. So Hello? Hello?
Hello, sir.
Yes, we can hear you.
Yes, that's what I had for you. Thank you.
Okay. Okay. Just yeah. Yes.
All right, sister.
And now
Thank
now
you
the now the graph is
for
visible.
that
Now the graph is visible.
adding.
Yeah. Now the graph is visible.
All right,
Do
but
you
as you have already presented, thank you.
do you have the box plot near you?
The box board, let me just check. Let me stop the sharing first.
Sorry, guys. I forgot to mention my name. My name is Rose Masanja. Thank you.
Okay. You people, are you able to see my screen? Are you able to see my screen?
Yes.
Yes,
It is showing what?
do file.
Slides.
Okay, fine. So like from our presenter say that a lot of interpretations in the details have been put it in the Google Colab link, the next video. So make sure you check it. You can also appreciate the PPTX which we made using the do file, which Mr. Yassini was learning it. So this is just a matter of summary. So Mr. Yassini has taken you through the setup, data cleaning, in the descriptive statistics, the graphs, the oil OS regression, logistic, probit, and the logic. So to summarize, uh, to summarize, we have used three data sets. The first one was students' data, which was XLX. So from that, it had some strings. So we generated new variables. For example, select your gender into genders number, like one representing male, two representing female. Type of family into family type. This was just cleaning the data so that it should look um, very accurate and precise, so that some codes also should be uh, seen. Yeah. After that, um, we have done the summary statistic, the bar charts, the heat map plot, the kernel density plot, as Wiz Masanja has explained about it, and also the box plot, maybe of which they are going to beam it. So from there, we create all the data set and load a new data set, which was wage one. The wage one, it was a detailed table. It was detailed data set. So from this one, we learned um, the oil regression. As you can see, the model there, wage being determined by education, experience, and tenure. And we urge you to watch the next video about Google Colab, so that much precise of these results have been interpreted there. Same applies. We did the diagnostic testing, whereby we tested for heteroscedasticity and multicollinearity. From there, we create our command and environment. Then we wrote a new data set, which was LBW. This is the internet-based data set from the STATA. So from there, we learn a logit regression, and we also identified the odds ratio. So We also did the marginal index, how particular unit change and affect the probability of something. For example, there we were talking about the breath being affected by smoking, race, and etc. So we encourage you to watch the next video to get more details about this. After dealing with that data set, we also imported another one old data set. It is also internet-based data set which is found on STATA. So from there also we did the probit model and we tried to summarize probit versus logit, and this was interpreted, and one member did this part to explain it. So we encourage you to follow us, and also make sure if you have question you put in the comment section so that we can come back to you and answer you correctly. Thank you.
Thank you, Mr. Gambili, for so helping us through that. So reaching this far, this marks the end of our presentation on STATA analysis using STATA 19. Thank you all for participating.